Welcome to the Learning Center. In this video, we'll talk about the complex numbers, their need, solving equations involving complex numbers, their graphs, absolute value, I, and its different powers. It's the part 1 of the 2 parts series on complex numbers. In the second part, we'll do the basic operations on complex numbers. I'll link that video in the description and in the card as well. I have also attached a worksheet link in the description for practice for free. Now let's dive into our topic. So what is the need for complex numbers? So first of all, let's understand with the help of an example. The example is solve x squared plus 25 is equals to 0. As we know that when we are solving it, we need to separate the variable from the constant. So we'll take the 25 to the other side, which becomes negative 25 when it goes to the other side. Now we want to get rid of the square, so we'll take the root on both sides. But when you take the root on both sides, it gives you plus minus. The square cancels the root because they are opposite. So I got the value of x equals to plus minus root of negative 25. I'm separating negative and 25 because I know that root of 25 is 5. Now what's root of negative 1? We don't know that yet. Now what's root of 25? That's 5. But what's root of negative 1? We don't know. What is the meaning of root of negative 1? Means I'm looking for a number whose square is equals to negative 1. There is no such real number. So we need to imagine that number. That is why it is called imaginary number, right? And it is denoted by the letter I, which stands for iota, and its value is equals to root of negative 1. So I can replace with root of negative 1 with I. So that is your answer for this problem. Or I can also write this as x equals to either 5i or negative 5i, because both of them are gonna satisfy this equation. Let's consider another example. X squared plus 200 is equals to 0. Now we'll take 200 to the other side, which gives you negative 200. I want to get rid of the square, so I'll take the root on both sides. The square cancels the root. The value of x equals to plus minus root of 200 and root of negative 1. Now to solve the plus minus root of 200, we need to take the factors, or we need to make the factors of 200, which is going to be 10 times 10 times 2. And root of negative 1, I can write this as it is. Now whenever there is a pair inside the root, we take a single number out, which gives you 10 root 2. Now what's the value of root of negative 1? We know that it's I. So the value of x equals to plus minus 10 root I. I can also write this as x equals to 10 root 2i, or I can write this as negative 10 root 2i. Consider one more example. 5x squared plus 80 is equals to 0. We'll take 80 to the other side, which gives you 5x squared equals negative 80. 5 is in multiply, so I'll divide both sides by 5. 5 got cancelled. I got x squared equals to negative 16, because negative 80 divided by 5, that's negative 16. To get rid of the square, we'll take the root. The square cancels the root, and I got plus minus. Now what is root of 16? That is 4. And what's root of negative? That's I. And that gives you your answer. So x equals to either 4i or negative 4i as your final answer. Now what if we are given two complex numbers which are equal? Just for an example, let's say we are given 3x plus 4yi is equals to 27 plus 12i. Now first of all, identify the real and imaginary part. So this is the real part on the left hand side. This is the imaginary part because it contains I. This is the real part, and this is the imaginary part. Now if two complex numbers are equal, then their correspondingly real and imaginary parts are equal. That means this real part is going to be equal to this real part, and this imaginary part is going to be equal to this imaginary part. So I got 3x equals to 27, dividing by 3, and I got the value of x equals to 9. And On the other side, we got 4y is equals to 12. 4 is in multiply, so I divide by 4. I got the value of y is equals to 12 divided by 4 gives you 3, and that is the value of x and y. Let's consider another example. It's 7x minus 2 plus 4y minus 3i is equals to 19 plus 17i. Now this is the real part on the left, that's the real part on the right. They are going to be equal. So I got 7x minus 2 is equals to 19. Take 2 to the other side, that makes it 19 plus 2, that's 21. 7 is in multiply, so we'll divide. So I got x equals to 21 divided by 7. That gives you the value of x as 3. This is imaginary part equals to imaginary part. Even in the same step, I'm ignoring I. So I'm getting 4y minus 3, that's equals to 17. 4y is equal to 17 plus 3, that's 20. Y is equals to 20 divided by 4, which gives you 5. And I hope you got it. Now complex numbers are denoted by the letter z. So let's consider a complex number z which is equals to 3 plus 4i. Now how will you graph this complex number? The horizontal axis in this case is called the real axis, and the vertical axis in this case is called the imaginary axis. Let's have the numbers on the axis. So this is the origin. On the right hand side we have the positive values 1, 2, 3, 4, 5. On the positive y-axis we have the positive values 1, 2, 3, 4, 5. Negative real axis, that's like -1, a little bit far. -1, -2, -3, -4, -5. -1, -2, -3, -4, -5. Now my real number is 3, so I'll go on the real axis from the origin and I'll go 3 points to the right. So it's 1, 2, 3. Now my imaginary part is 4. So I'll go plus 4, means I'll go to the positive side of the imaginary axis. So this is the imaginary axis, right? So that's going to be 1, 2, 3, and 4. So this represents your complex number z, which has the real part as 3, imaginary part as 4. So that is 3, 4. So this point represents that complex number. Now if you join this origin with that complex number, this distance from the origin to the complex number is called the absolute value of that complex number. How will we calculate it? Now if you look at this triangle, this is a right triangle, right? Now in a right triangle, the square of the hypotenuse is equal to base square plus altitude or perpendicular square. Now I want to get rid of that square, so I'll take the root on both sides. In this case, I'll ignore the negative value because the distance cannot be negative. So the square cancels the root. I got z mod or z absolute value is equal to root of 9 plus 16, which is equals to root of 25. So I got the absolute value of this complex number is equals to 5. So the concept is, so whenever you have a complex number z which is equals to a plus bi, you want to find its absolute value. That's equals to root of a square plus b square, and that is going to be your answer. Now I, the value of I, as we know that it's root of -1. What if I do the squaring on both sides? Now everybody knows that the square cancels the root. The value of I square comes out to be -1. That is the first concept which we need to remember because it's going to be helpful to solve higher powers of I. What if I do the squaring on both sides once more? I got I square equals to -1 and I'm squaring on both sides. Now when there's a power of a power, you multiply them. 2 times 2, that's a 4. And -1 squared, that's -1 times -1, which is equals to 1. So that's the most important relation to solve the higher powers of I. So I raised to power 4 is equals to 1. That's my first preference, always. Now find the value of I raised to the power 3. I can write this as I square into I. Now I have the value for I square, so I can plug it in, which is negative 1 into I. So finally we got the value of I raised to the power 3 is equals to negative I. So that is the third value which I need to remember to solve the higher powers of I. Now let's take some of the examples, but before that I want to write the values we have. The first value we have is I square, which is equals to negative 1. The second and the most important in this case is I raised to the power 4, which is 1. The third is I raised to the power 3, which is equals to negative I, right? So let's consider the first example. What is the value, or find or evaluate I raised to the power 20? As I told you, my first preference is I raised to the power 40. Now what should be the power of I raised to the power 4 so as to get I raised to the power 20? Now what should I multiply with 4 to make it 20? That's 5, because when there's a power of a power, you multiply them. Now plug in the value for I raised to the power 4, which is 1 raised to the power 5, and 1 raised to the power 5 gives you 1 as the answer. Evaluate I raised to the power 37. I can write this as I raised to the power 4 raised to power what? Now what should be this number so as to get a number which is less than or equal to 37? Now 4 times 9 is 36. I know that. So here is the power 4 times I raised to the power 1, which is separate. Plug in the value for I raised to the power 4, which is 1 raised to the power 9 into I, which gives you I as the final answer for this problem. Consider this example, I raised to the power 51, which is equals to I raised to the power 4. Now 4 times what gives you a number less than or equal to 51? That is 12, and we have 3 more powers left. You can check this out, or you can solve this with the help of long division. Now I'm dividing 51 with the 4. 4 times 1, that's 4. Now 51 minus 4, that's 1, and bring that 1 down. 4 times 2, that's 8. Now what's 11 minus 8? 3. So there are 12 complete powers of 4 and 3 separate, which is on the side. Plug in the value for I raised to the power 4, which is 1 raised to the power 12. Plug in the value for I raised to the power 3, which is negative I. Now when you multiply them, you get negative I as the answer. One more example. What is the value of I raised to the power 26? I can write this as I raised to the power 4 raised to the power 6, because 4 times 6, that's 24, and we have 2 powers of I left. Plug in the value for I raised to the power 4, which is 1 raised to the power 6. What's the value of I squared? That's negative 1. And when you multiply them, you get negative 1 as an answer. So please do practice with the attached worksheet in the description. If you like this video, give a thumbs up and subscribe to my channel. If you have any doubt or any topic I should make the video on, please comment.